Welcome to the first session of GH-200, Automate Your Workflow with GitHub Actions. I'm Rob Folkrod, a Microsoft technical trainer and longtime MCT in the developer and DevOps space. In this first module, we're going to be looking at getting an introduction to GitHub Actions. Specifically, we're going to first get an idea of what its purpose is. But then we will quickly go into, let's take a look at the files themselves. So we'll look at the YAML file and its basic structure. We will then take a look at the events and the triggers that will cause your actions to execute. And then we will take a look at what is the space in which your GitHub Actions will be running. So first, let's just have a quick conversation about why we're even here, right? That in the developer world, there are a lot of things that have to happen on a regular basis. Right? We need to ensure that our code consistently compiles, that our unit tests are passing, that our code quality is staying high. That's on one side of the equation. We then have to run our code through a series of environments that will be testing the code base, that'll be ensuring the security of the code that's running. And then we'll need to push that into maybe a series of environments where we are preparing and then finally dropping it into production. These are things that we have in the past done manually, where we have human beings who are going to be there, who are going to be clicking on the things and running those tasks. But as we need an increased amount of speed, we're going to need an increased amount of automation. And GitHub Actions is the native product built into GitHub that can perform, whether they be continuous integration, CI tasks, whether they be continuous deployment tasks, CD tasks, or whether they be just the living and breathing of our regular repository and its ongoing activities. GitHub Actions is that automation tool. These are things that GitHub Actions could help automate. Right? It could be running your unit tests. It could be running the code quality tests. It could be ensuring that various dependencies are kept up to date or are in compliance with your own internal policies. These are all things that individual actions in your entire workflow could be running. So where do we find them? As we said, they are the native product of GitHub, so it will be relatively straightforward to find that inside of your repository, there is a menu item in there called Actions. And if you don't have anything in there, you get a nice little Get Started component. In this Get Started component, it will look at your repository, and it will then kind of guess what are the basic templates that might jumpstart you, that might move you forward. Later on in the course, we're going to be taking a look at how we can offer up our own templates that are going to be there, but it will just start with, hey, this might be a good starter workflow that you can either choose or build your own. Let's take a look. If you are going to build your own, what is it going to look like? What is the component that's going to be there? And so the product name, I don't know, maybe it's a little bit tricky because we call it GitHub Actions. But the reality is, most of the time, you're going to find yourself not in the low-level actions, the individual minute steps, but you're going to be working on the workflow as a whole. So the two terms that you want to be familiar with, there is the three really, is the GitHub Actions, the brand name. Beneath that brand name, what you will be building is one or more workflows. And here we have a very small, very simple, but sample workflow. A workflow is going to be a YAML file that you are going to create and that you will then check into your repository. Now, in some product, it really doesn't matter like where you check it in your repository, you kind of put them anywhere. GitHub Actions, it matters. That there is a very specific directory that we're going to be looking for. And that is the .github/workflows directory. Anytime you commit a YAML file into that particular directory. GitHub Actions says, I know what that is. I'm going to be taking a look at that. And so this is one very small sample. You can see here that we start off with just a quick little name so that we know what to expect when we're looking at it. Then we're going to delve a little bit deeper in there, and we're going to have an on. This can be either as simple as what we see right here, or can be very, very complex. But it describes, why are we going to run? What is the thing that's going to happen outside of our workflow that will then invoke this particular workflow? So in this case here, if anybody, anywhere, commits to any branch, right, we push commit up to that branch, the workflow automatically runs. We can get a little bit more detailed, and we will in a moment. So this is the when, right, what we're looking at right here. This is the when, but then what are we supposed to do? And that's going to have one or more jobs. The job section, you've got to have at least one, but the job section here describes what is the process going to look like. So in this case here, we have named the job build. It can be whatever you want, right? But we've named it build. And we have specified the machinery that it's going to be running on. In this case, it's going to be running on a Ubuntu server. More specifically, what are the concrete things that we are going to be doing? And that's going to be a step. Steps section is going to then have the namesake for the product, actions. And so each one of these right here is an individual action. So to recap, a little bit more visually here, anytime you're looking at a workflow, you're going to have one workflow file. That's the YAML file. Inside of the YAML file, you will have one or more jobs. A job has a mandated steps section. And then the steps section is going to be your individual actions. There are a lot of actions out there. As you can imagine, there are a ton of different developer platforms, a ton of different security tools, a ton of different testing tools, and all of those need some mechanism to run on these machines. So you have to then find the appropriate action. And there are a number of different spots where you can look to get those actions. First, there's a built-in collection of actions. If I need to check out my code base, and you probably at some point in time will need to check out your code base, there's an action to check out that code base. But then there's going to be everything else, both GitHub, Microsoft, and third-party tools available to us. And you're going to find those at the GitHub Marketplace. In the GitHub Marketplace, there will be a huge collection of actions that you can then include in your individual workflows. You could also rely on external open source projects. Anybody who builds an action, you're not obligated to put those into the marketplace. Right? So there may be some out there that are not in the marketplace. It's a little easier to find them, but there could be just any open source product. Or, and very likely, you may end up building your own. Now, we will spend time really in section 3 talking about building our own. But very quickly, we've just got a few options here when it comes to building our own. And so here we're talking about, if I'm going to build my own, what are the avenues that we could go through? And I'm actually going to do these in the reverse order on the slide. So the first one over here, this idea of composite action says, hey, I've already got a bunch of YAML files. In those YAML files, there are a bunch of actions that I've already built, but these 4 actions, maybe it's the, what does it take to do a decent build? Right? Every time I do a decent build, I have to go and do a checkout. I might have to move a couple files around. I might then have to run a build tool. Right? All of I just do these every single time, but I've already written it. Right? Take that, and we can make that into a composite action. Right? We don't really have to do a heck of a lot of work. We just extract that component. We've got it as a composite action. It also may be that we're going to need to do a little bit more work that would require some sort of programmatic access. And this is where we can delve into kind of a common process. Many of the built-in actions are written in JavaScript. You can use either TypeScript or JavaScript, but ultimately they will be written in JavaScript. And that gives you the entire programming realm in which you can control what those actions are doing. So those can run on any of those environments, on Linux, on Mac, on Windows. There would be, in essence, a version of Node will be dropped in and run your action. However, some of you might not be the biggest, maybe not even fans, but you've already got something written in some other language, right? Whether it be in Python or Ruby or whatever language. And in that case, you can bring your own development environment in there. So an action could be run by way of building a little container around that. In a container, you can bring your own dependencies, you can have it built, and then your action can be built on those container actions. Again, module 3, we'll see a little bit more detail in there, but just know that your workflow will be composed of either the built-in actions or you'll be building your own. But when do these actions run? What invokes these actions? And the answer is we've got a lot of different events. An event happens, which is then a trigger. And you'll see both of those terms, and sometimes they use them interchangeably. But an event happens, that is then a trigger in your particular workflow. Now, if you go to the documentation, you will see that there are dozens and dozens of potential events that could trigger your workflows. We're not going to go through all of those. I would recommend that you hit the GitHub documentation and you take a look at a collection of those. But we're going to see in here some of the more common ones that you might use in a continuous integration, continuous deployment workflow. So the very first one that we're looking at in here is I need this workflow to run not necessarily when a particular thing happens, but at a particular time instead. So we have a scheduled event. So the schedule event uses the cron syntax that some of you may already know. If not, while it looks a little bit cumbersome here, they're really not hard to build nowadays. Open up your favorite Copilot, tell it exactly what you want. It'll build these faster than we can anymore. So it's not as cumbersome as it used to be back in the day. But basically what you're looking at is a simple string, and that string is going to have 5 different components. There will be the minute that you would like it to execute. There would be the hour that you want it to run. Then the day of the month, if I want this on the first day of the month or on the 15th day of the month. We've got some sort of numeric value, 1 through 31. Then maybe it's only certain months. Maybe we only want this to run January, February, March. We could have the 4th component there. Maybe more likely, however, the 5th option there of day of the week, where we could say this needs to run on Friday nights, or this needs to run Monday mornings before our developers get into the office. All right, so as a quick little example, you can see here that we have 5, 4, 2, then a couple of stars. So read a little bit backward because we do have minute followed by hour, but the hour 4 o'clock. So whenever we hit 4 o'clock, and that's on a 23-hour clock there. So at the 4 o'clock hour, then at the 5-minute mark, and then in this case, only on the 2nd of every month. I don't know that that's incredibly likely, but we just need to show one other value in there. Now, what might be a little bit more practical, we're going to take a look at a couple other real-world examples that might be in your workflow itself. So our on is always the node element that we're going to be looking at for our events. And so in this case, we say on schedule. And underneath schedule, you will specify the cron option. And so in this case here, of our 5 sections, we start off with one that is */15. So in this particular scenario, what we're looking at is any, think about it, what was that one? What was the first one? minute, right? So here at any minute that is evenly divisible by 15. Right? So at the 15, at the 30, at the 45, back at the top at 0, it's going to run on one of those. So this then runs every 15 minutes. If we look over here, we're going to see, again, one that's kind of practical here, Sunday nights at the 3 o'clock mark. Right? We're going to have these run kind of in the middle of the night. We may have some security examinations that may take a fairly long time to run. And so when no one's around, when fewer folks are around anyway, we'll have that run. And it might run for a couple of different hours, a couple hours at that point. But it runs Sunday nights at 3 o'clock in the morning. So schedule, widely used. One that is also pretty common, but maybe a little bit more obscure in the GitHub world, is one called workflow dispatch, a really important one. In other platforms, when you have a pipeline or workflow, right, there's often a button that you can just click to run it right now. And by default, GitHub Actions don't have that. I very specifically remember a number of times where I'm doing some sort of debug process and I just needed to run again and again and again, where I'm debugging a few things. And the only way to do it is to kind of push new changes. So I'm opening up a file and I'm like making a goofy comment and committing that again and again and again. An absolutely horrible thing to do to your repository. Wouldn't recommend. Instead, workflow dispatch. Workflow dispatch is a tricky way of saying manual. I just want a button. So when you have a workflow that has the on workflow dispatch and, a little addition here, and that YAML file has been committed to the main branch. You're not going to see it until it gets into the most important, that main branch. When you get those two things as true, then when you go into the workflow itself, you will see that you have a button that you can click on to just run. Now, if you just have these two, right, perfectly legit, if you just have those two, button, click it, run it, it's fine. However, we also could get a little bit more detailed. This inputs section right here, get that zoomed in a little bit, this input section right here, completely optional, but it gives you a way of passing in parameters. So in this particular scenario, we have a log level parameter and a tags parameter. They could be whatever you want. They're strings. Go wild. In this case, log level, and we're giving a description of what log level is supposed to be. This does have to be kind of the variable identifier syntax, so they're not always as human readable, so a little description allows you to make it slightly more human readable. And then whether it is required and what a default happens to be. Right. And then finally, tags, which we have a description for as well. So when you go to run this, you'll click the little drop-down button. You'll click the little drop-down next to the button, and you'll see little inputs for, in this case, log level and tags. So when you want to be able to run specific instances, then workflow dispatch with parameters. Now, this is at the user interface, but in the DevOps world, we really want to try to get away from humans clicking on stuff. So we also have a second version of manual, and that is called repository dispatch. Repository dispatch is really, I'd like a REST API. I would like the outside world to be able to call in and invoke this particular workflow. So if you have, maybe you've got some other tool that's doing some sort of build, and when it completes, then you need to kick off. Your workflow needs to kick off and do something. Maybe you need to integrate another application. So you've got an application, that application a user is using, they click on something, and they need your action to then run. So on a workflow by workflow basis, you can go ahead and build the repository dispatch. What that's going to look like is you will have the on, like every other time, name repository dispatch, and then you can optionally include some sort of type. Right? So maybe there are a couple of different reasons that you want this particular automation. Here they've created the idea of opened and deleted arbitrary terms. You can call them what you want. But then you create a REST call. In this case here, we see we're using this by way of curl. We are calling into api.github.com repos, the organization, the repo, and then into dispatches. And then finally, here we're adding the event type. That just would want to match one of the values that we have on the other side. So now it could be either a person clicking on a thing or some external tool or API invoking it. Now, all of those, so we saw scheduled, and we saw 2 manual approaches. They're widely used. However, in the world of continuous integration, continuous delivery, we also need things that are a little bit more automatic than that. And so here we have 2 very common triggers that are used in the CI world. We have push and we have pull request. So push is someone has made a commit and pushed that commit up into a particular branch. So we see in our example right here, again, inside of on, we're looking at the push event. And specifically, we're then starting to filter a little bit further. And maybe there are a number of branches in there. If I go create my own user branch and I'm doing a little bit of test work, we don't want a build to kick off because I'm in my own separate world. Right? So we're specifying in this case, if you are pushing to main or the develop branch, then we want it to run. Otherwise, sit back and relax. So anytime a commit is happening, but also a pull request, right? This is a bigger opportunity. Someone has packaged up a bunch of commits. They would like to have those brought into your branch. And so they've gone through the process of creating a pull request. Again, we get to have a little filter here on what branches you want. There are, if you go take a look at the documentation, there are other filters in place so that pull requests go through a series of events themselves. Pull requests are created, and pull requests are updated, and pull requests are closed. You could also have filters on those as well. So on the CI world, those are 2 common ones. Again, hit the documentation. You'll see there are dozens of events possible, but those are pretty common for the continuous integration realm. On the continuous delivery, on the continuous deployment side of things. Again, push, nothing really new on that one. But here we have an opportunity for like a release. GitHub has this concept known as releases, where someone can go make an official release. And maybe in your world, when a release is created, you then need to deploy that to 4 or 5 different servers. Cool. So here, a release kicks in. Again, we have a filter. Releases can be created, but there might be a series of steps that they have to go through after they create that were not quite official yet, so they can then go through a published phase. And so here, we really only care, we're filtering that down to we only care about when they are indeed published. Right. Lots of events available to us. We may see more throughout the course. That's kind of our basic collection. We have had our time-based schedule, our manual with repository dispatch and workflow dispatch, and we have kind of the more automatic ones like push, pull request, and release. But now it's been triggered. Something has happened. Where does it run? What executes it? We're going to need some form of compute. And in the world of GitHub, we have what are called runners. Now, these runners come in a couple different varieties. There is what's called a GitHub hosted or self-hosted. So GitHub hosted, you don't want to have a lot of baggage. You want someone else to maintain those systems. So the GitHub team has a number of servers that are Windows, Mac, Linux, and you can then choose to have your code run on their servers. So inside of the on, you can just specify the runs on Windows latest, runs on Ubuntu latest, or runs on Windows, and you can specify one of the versions that are possible. Your code will be packaged up and then run on those virtual machines. But there are some downsides and some things that might make that impossible. So, for example, visibility might be an issue. The GitHub are cloud-hosted servers that probably don't have visibility into your internal networking systems. So if the cloud version of this runner can't see into your environment, it certainly can't deploy something to your environment. What you may need to do at that point is have your own runner, a self-hosted runner. You will build a machine, a virtual machine, inside of that environment, and you will install the runner agent on that particular machine. You'll point it back to your organization and say, I am now a part of that team. And then you can specify that your workflow runs on that particular runner. And now it has the visibility into the rest of your environment. Visibility is one. It might be that you have special software requirements, that this particular build can't run without having something pre-installed, and that installation may take longer than what you want to do inside of a GitHub hosted environment. GitHub hosted, you're going to be paying for the minutes. And maybe if we have to install the software every single run, you might be consuming a lot of extra minutes in there. So you don't want to go through that process. You'll pre-install that on those systems. Right? Just a couple of examples of when self-hosted might come into play. It might be that you're using the enterprise server version, which is already on-prem, and you are isolated from any cloud environment. You're just not getting to a GitHub hosted runner, and you're going to have to build your own. So we will talk in a little bit more detail in section 4 when it comes to kind of making some decisions and how we can create some policies that'll control these. But once we have them up and running, there may be a time where you say, I don't want it to run anymore. This isn't working. It could be that you're making some changes to your infrastructure. And while you're doing that, it's not a good time to start pushing new things to that infrastructure. It could be that you are rewriting part of your application, and you know for a fact that as we are in this rewrite, stuff's going to break. It's just not going to run, and we don't want to have to pay for the minutes of seeing failure after failure. So we just need to disable the workflow. So to disable the workflow, we see a quick little example here. We see that we have a number of workflows. One is called the grading workflow. That grading workflow we have clicked. You can see the highlight there. We go up to the 3 dots, and from those 3 dots, simply choose to disable the workflow. At this point in time, we really don't care what events kick off. We're not going to trigger. We're not going to run it until you go by and re-enable that workflow. What you're not going to see, what you don't see in there is delete. You're not deleting the workflow. Your workflow is a file in your repository. So as long as you have xyz.yaml sitting in the .github/workflows directory, as long as it's there, you're going to have a workflow. If you want to delete it, go to the file, delete the file itself. But each workflow, every time it runs, creates a workflow log. And so what you may want to do, that log is called a run, right? Every time it is invoked, there is a run of your workflow. So what you might also want to do is just go and delete some runs so that we know there's 12 errors in a row. Great. We've been fixing it. It's now fixed. They're not really relevant to us anymore, and we want to go ahead and delete those. You can delete individual runs through the interface, or you can also invoke a web, a REST API, delete repos, the owner or the org of that repository, the name of the repo, the actions, run, and then specify the run ID. Every time you invoke it, you get a particular run ID.
All right, folks, let's take a look at putting this into practice a little bit. So what we have in front of us right now is a repository that is a simple node-based application. And as of right now, there are no actions, no workflows inside of this particular project. You can see that where the .github folder should be, we have nothing. And even if we scroll down just a little bit, you'll see that GitHub here is suggesting that we go ahead and add some workflows to do the continuous integration, continuous deployment, potentially, of this particular application. So if we scroll up to the top to Actions, where they belong there, we'll go ahead and click on Actions. And the first thing that we're going to see at this point is the template suggestion. So you can see it looked at our repository and it saw the contents. So this was a Node application. So right now it is making Node-based suggestions. If it guessed wrong, we can scroll down a little bit further, we can see that there are a number of other templates waiting for us here to pick those and have those as our jumping off point. But in this case here, I'll just start with a relatively simple template. And I'll go ahead and click Configure. When I do, it is adding for us, you can see right here at the top, into our repository, into the .github and workflows directory. It is adding an npm-publish.yaml file. We could name the file here, whatever seems appropriate. And it's giving us a starter, something to begin our workflow with. Over here on the right-hand side, it is also listing out a number of actions that we could bring into our workflow. These here from the marketplace. You can see the sample is using a couple of these actions. We're using the checkout action and then going in and setting up a particular version of Node in this case. But I have a slightly more compelling workflow right here that I'm just going to drop in that exercises some of the ideas that we have seen in the module. So I've given it a very simple name here. We're just doing a CI, and there are a collection of events that we discussed a few moments ago. We'll double back to these in just a second, but if we scroll past all of the events, we will see that we have a number of jobs. So here we have the build job. And the build job is a collection of steps, as we have seen. And in this case, again, we're going and doing a checkout. We're doing a little bit of work here with configuration. The actual steps are not incredibly relevant to us right now. It's more the structure. We're doing a little bit of configuration. And then we are running our setup, right? We're getting the Node version installed that we're going to be using. From there, then we're just running tasks. This is just at bash, going ahead and running npm CI, then going ahead and running a validation. Then we'll go and run whatever tests we need to execute at that point. Generate code coverage. If it was run in the correct manner. We'll see that in a moment. And then uploading the results of that code coverage, right? So that's one job that we have. We have a compatibility job. Compatibility job was actually running something very interesting. We didn't actually talk about this in the module content, but it is going through and running what's known as a matrix. So in this case, we will run 3 times. We will run for node 18, we will run for node 20 and node 22. So we've got this node version matrix, and down here inside the run, you will see that we will say node version, and we are pointing back specifically here to that node version. So each edition, each instance will run a different version of node. And then we have a notify, a very simple job here at the end, which we're just outputting to a special GitHub variable to get a GitHub step summary. All right, so that's the gist of it. We'll come back and look at a couple components as we go, but I'm going to go ahead and commit this into a branch. So we will commit this specifically into our feature / workflow demo branch. And we'll give that a run. So pull request is now about to be made. We'll go ahead and create that pull request. And immediately when we go into actions here, what we're going to see is we're going to see 2 runs. The action that we just created has a couple of triggers in there that are interesting to us right now. There is a push trigger in there, which required the first run, and there is a pull request trigger on there as well. So both of those are running. In this case, it's the same code, so we don't really care which of those is running. But we will see if we go and dig into one of these that we ran relatively quickly here. We're pretty much done at this point. The 3 jobs, the build and test job, the summary job, those 2 already ran. The matrix had a qualifier in there that only runs under certain circumstances. So we'll go ahead and take a look at that. But then at the end, we get our summary here that we had a successful build, and it was because of a pull request. So life is pretty good at this point in time. Let's go take a look at those events. So we will swing into the action. We'll go into its code here and into the branch where it lives right now, which is the workflow demo branch. Into workflows, and we will open up that YAML file. So let's take a look at those events. So the first event here is the push event, and we do have some filters on the push event. It's not every push into this particular repository, but only into the main branch or in any branch that has the prefix of feature / So you saw that I published to the feature workflow branch there. So that ran. We also have a path ignore. So if we were to modify, for example, the readme.md file, that really doesn't have a lot of bearing on the build of the project. So we're saying don't bother with that one. You will also see a second. This is our pull request. If we are making any pull requests into the main branch, this one will work. We also have a cron job in here. We saw that ability to schedule. And so this one here will run at 6 o'clock in the morning every single day. We will see it runs. We also, in our earlier discussion, saw 2 ways of doing a manual push. And so we have workflow dispatch. This should create for us a button. We'll see that it's not quite there yet, but when we do have this, it'll have a series of inputs. We will be able to decide the node version. We will be able to decide whether we want to run code coverage or not, and we will pick an environment. And then finally, we have the repository dispatch. This is the API structure. So let's go take a look at those relatively quickly. We're going to go into our pull request. Well, let's go into the action first. In our action, we'll click on CI. And in theory, right here, we should have a button that allows for that workflow dispatch. And you see it's not here at this point in time. And it's not here because the workflow is not in the main branch. So we will go into our pull request. And we will accept this pull request. We'll do a little squash and merge, bring that into the main branch. We will delete the background branch just so I don't get confused. And with that change, we're going to go right back into actions. What we did was we took the workflow that was in a background branch, we brought it into that main branch. And now when we go to actions and when we click on CI, we then have our run workflow, right? This is the workflow dispatch event capability. And we click the drop down in there, we will see that we can pick, if there were multiple branches now, we could pick what branch we wanted to run on. And then those three inputs, the node version here, which allowed us to pick from one of three versions, the checkbox, should we have code coverage, and a name for that development environment. So we can go ahead and run that workflow right now. That is then should kick off. There's our CI manually by me. Right. And let's take a look at running this by way of an API as well. So I'm going to drag just a little bit of code in here. We have our Visual Studio Code here with a little plugin called the REST client that allows us to make REST calls from here. We will be going into our project with our or into our organization with our repository name right there. And the first thing that we're going to do is just do a little check in here to see what are the workflows that are available. When we send a get into our repository there, it'll come back with a list of workflows that are available to us. In this case, we have the npm publish is one of those workflows. As a matter of fact, it's the only workflow that we have in there. So from now that we know what workflows are there, we can then call into an individual workflow. So we'll go and make sure that we've got the appropriate name. We do. Life is good there. And we are going to then do a post into our organization, into our repository. And we're going to specify the workflow URL that we want to execute. We also have one of two different event types. We'll double back and you'll see which one we're running at that point. We'll go ahead and send that request. All right. The response we're getting back is a 204. 204 says, yes, everything worked. I just don't have anything much more to tell you about it. There's no body, no content that should be expected. So if we swing back into the workflow, we will see our build and test version also ran. Right? So that's running right now. Going back into the actions just to see those two components. Again, as a reminder, our workflow dispatch had those three inputs. It had the node version, run coverage, which was a Boolean there, and the environment, which was a string. Those were those three options inside of the button. And repository dispatch had a build and test option and a deploy trigger option. So in this case, we chose build and test as the mechanism. Right, so a number of different events could be are illustrated right here. All right, now let's imagine, we're going to go one step, we're going to kind of put this to bed now. Let's imagine that we're doing some form of change beneath the covers inside the code base. We know for a fact that our builds, they're going to fail for a little while. There's no point in having it run every single time. So we'll swing back into our actions one final time. And into those actions, we will go and click on the CI run. And up into the 3 dots right here. From in here, we can go ahead and disable the workflow. Now that it's been disabled, no amount of change or call into any of those triggers are going to execute it again. So if I were to swing into the code and into the data in this one, and let's go into one of our questions here and change the correct answer to 2 and commit that change. This is a push specifically into the main branch. So that should trigger that push trigger. If we go into actions, what we're going to see here is it did not. We just have the last 2 manual ones that we ran. A new one isn't popping in because it is disabled. Now, what you don't see in here when I click those 3 dots is you don't have a mechanism in here to delete. We can disable, but we can't delete from here. To delete the workflow, you want to delete the file itself. You would want to go into the .github directory in the workflows subdirectory and then delete the file out. I hope that was helpful. Let's go wrap up the class.
This has been a start. We've got a lot more to do. But in this module here, we have seen our YAML files and our creation of what it takes to build a workflow. We talked very briefly about the kind of actions that we're going to see in there. We also saw the triggers, like push, that runs every time you do a commit, or some of the manual ones, like workflow dispatch and repository dispatch. And then we saw that we have this idea of runners that are there to invoke. We're going to spend a little bit more time on actions and runners, all coming up in future modules. The very next module is going to be looking at a deeper dive into pipelines. What are the tools that are available specifically if I'm building a CI or a CD pipeline? What are the things that can help us there? I hope you'll join me in that section, and I'll see you there.